Welcome to General Chemistry Mini Lecture Series, Lecture 25, First Law of Thermodynamics. In order to understand thermodynamics, I need to introduce you two new terminologies. One is a system, the other one is surroundings. System is the material or process we are studying the energy changes within. Surroundings, that will be everything else in the universe. For example, if we are studying a particular chemical reaction, then that reaction, which means reactants and products, those are the system. Then everything else, that will be the surroundings, that including the media. The first law of thermodynamics is also called the law of conservation of energy. It simply states energy inside a closed system must remain constant. Energy can neither increase nor decrease without interference from the surroundings, which means the outside. Energy can be transferred between objects by some combination of either heat or work. Or we can write a simpler equation here. Delta E, the energy change, can be calculated by heat and work. And sometimes you will just have heat, and sometimes you may just have work. Energy can be transformed from one form to another. For example, heat can be transformed to light or to sound, and so on and so forth. Let's work on one example. Here we talk about a chemical reaction inside of your car engine, and then the products of the reaction, they are gases, CO2 and water vapor. Expanding gases, they do 455 joules of work, and the system also loses 335 joules to the surroundings as heat. We need to calculate the change in energy, delta E, in joules, kilojoules, and kilocalories, lowercase c. We have to find out what are given, or what do we know. We know heat is 335. Why is negative? Because the system loses giving off energy. So then it has to be negative. And then the work the expanding gases do is 455 joules. And why this one is negative? Because the system does the work. If the system does the work, it's negative. And then we need to find out delta E. First, let's recall the key equation for the first law of thermodynamics. Delta E equals Q plus W. Heat plus work. We just simply replace Q and W using the values given in this question, and that gives us negative 790 joules. We found out the answer for joules. Now we need to convert from joules to kilojoules. Negative 790 joules, we are going to convert from joules, place joules on bottom, to kilojoules, place kilojoules on top, and then that gives us 0.790 kilojoules. Next, to find out the energy change in kilocalories, we start with kilojoules, and then we are converting from kilojoules to kilocalorie. 1 kilocalorie is equivalent to 4.184 kilojoules. You may ask me right now, where did you get that relationship? Yes, I did not give you that direct relationship, But in the previous slide, I did give you 1 calorie equals 4.184 joules. So therefore 1 kilocalorie equals 4.184 kilojoules. Kilojoules are cancelled. Now we have 0.189 kilocalories. That's how we solve this problem. Now let's talk about the state function. Internal energy is the total amount of kinetic and potential energy a system possesses. Then the change in the internal energy of a system only depends on the amount of energy in the system at the beginning and the end. Okay? What does it mean? The energy change does not depend on the path. Okay, for example, you see here, well, one person reaches the peak in 15 minutes, the other person follows this path and reaches the peak in 30 minutes. But the energy change for both hikers are the same because the energy change only depends on the final energy and the initial energy. The final energy is the same. The initial energy is the same for both hikers. So therefore, the energy change in this case is called state function. It only depends the initial and final states or conditions, and not on the process used, not on the path actually used. That's called state function. For chemical reaction, actually, we can calculate the energy change of a given reaction. Simply use the energy of the products, that's the final, subtracted by the energy of the reactants, that's the initial, because all of reactions always initially start from reactants and then end up with products. If we consider the y-axis as internal energy, and this is the initial state, lower energy, and this is the final state, higher energy in this case, you see the energy is added to the system. Therefore, delta E is positive. We call that endothermic. The opposite process is called exothermic. You see the initial energy is much higher than the final energy. So therefore, energy is removed from the system. That's why we give that a negative sign. And this is called exothermic. Energy can be exchanged between system and surroundings through either heat, work, or both. If the system receives heat, you see the heat flows into the system, we give that a positive sign. That's endothermic. If the heat flows away from the system to surroundings, we give that a negative sign, which means the system loses heat. And that is called exothermic process. For the work, if the work is done on the system receives the energy, positive, endothermic. If the work is done by the system on the surroundings, we use negative sign, which means the system gives off energy to surroundings by doing the work on surroundings. Q means thermal energy or heat. W means work. In cases of the work done by compression or expanding of a gas, the work can be calculated using pressure times volume. Sometimes we call this as a PV work. Heat and work are not state functions. Their values depend on the processes. However, delta E is a state function. For endothermic processes, we use positive sign for the values. Positive means the values should be greater than 0. If the system gains heat, the sign for Q should be positive. When system gains energy from work done on the system, the sign for W should be positive. When the system gains internal energy, the sign for internal energy, delta E, should be positive. Exothermic process is exactly the opposite. Negative Q means system loses energy. Negative W means system releases energy by doing work on surroundings. Negative delta E means system loses some of its internal energy. Here shows the first two quiz questions in lecture 25. I'm going to work on question number 2 with you guys. This is very similar to the example I showed you a few slides ago. This is talking about the chemical reaction inside of car engine producing CO2 and water, and the expanding gases do 510 joules of work, and the system loses 455 joules to surroundings. We need to calculate the energy change in joules and kilojoules. First, recall the key equation. Energy change equals Q plus W. Okay? And now, what is Q? The Q, or the heat, in this question is 455. In order to determine whether it's positive or negative, we need to see whether the system gains or loses the heat. Here says system loses this much heat, then that's negative. And then W. W, the work done by the expanding gas, that's 510 joules. Since the expanding gases are part of the system, so therefore the system does the work, which means system loses this much of energy. So therefore has to be negative. Now we have negative 965 joules. We got the answer for joules. Now we need to convert from joules to kilojoules. Joules converting from, put that on bottom so that joules and joules can be cancelled. And then to kilojoules, 1 joule is 10 to negative 3 kilojoules, or 1,000 kilojoules. All right? Okay. And now we have 0.965 kilojoules. C is the correct answer. And you can keep working on question number 3 and 4. I will see you guys in lecture 26.